Yo, what's up, chat? This is my C++ Minecraft clone. Today we're doing something different. We actually scheduled the stream. Hopefully I managed to make it work. But just in case, I'll wait to be sure it's working, the schedule stream. Yeah, chat, we live, right? What happened with the schedule stream? Is this the schedule stream? Because this is the first time I'm doing a schedule stream, chat. Oh, it's not the schedule stream. Yeah, my bad, chat. I'll remove the schedule stream. Yeah, that's a bit of a bummer. Yeah, I removed the schedule stream, chat. I'll need to figure it out for next time, chat, on how to do a schedule stream. That's a bit of a bummer, but we'll figure it out at some point. So, chat, we'll start with a summary of the game for new people. Then we'll decide what we're going to do today. And at the end of the stream, we'll do a summary what happened during this stream, which would be in about 3 hours, chat. And I think probably we should have even text to speech, probably, but I'm not sure. And I set some kind of a limit to not be for any super chat. I don't know, but it will probably not work. Most likely it will not work. I tested a lot of things today, and I'm expecting everything to break. So it's fine, chat. So let's do a summary, chat. Let's do a summary. So this is my game. It's made in C++ and Raylib. And yesterday, we focused on generating items from pixel art. Okay, this is the lava. Look at how now, before we were holding lava, and now we're holding a lava bucket. And here, this is the water, etc. So we have fluids. Also here, look at this, chat, we have a sword. We have a sword. The problem is with the positioning. The position is not correct and the rotation not correct. And maybe we need to make it a bit larger. So this is the sword. We have an actual sword. We have mobs. Here we can do the creeper. And maybe in this stream we can hit the creeper. Maybe. Also here we have redstone. We have redstone, chat. And here we have poppy flower, dandelion. All of them are finally using pixel art. This was a big struggle, but we managed to figure it out. We just need to slightly correct them, chat. Anything else of importance? Yeah, okay, we're doing the summary. So here we have TNT. We have TNT. It explodes. It activates the other TNT. Also, we have farming. We have here the wheat we can use on the farming. Here we have farmland. And we can use it. Yeah, I don't know why this crashes. We'll just restart it. Maybe from yesterday we've broken the wheat. Did it restart? Game. Okay, now it should start. Also, what else do we have? We have portal. We can travel to other dimensions. Here we can create a portal. We can create a portal, but you can also see it from all of the previous streams. It's fine. We don't need to show absolutely everything. But yeah, we can teleport to Nether. We can go back. We can go back, etc. We can go back. And also we have custom block outline. This is the custom block outline like this. And we also can go in F5. We have Steve. Animation is Steve jump scare. We have Steve. And we have rain. This is our rain chat. The cool part is it doesn't rain here. We have a roof on top of our head. We have clouds which are not endless, but in comparison to that, the terrain is endless. At least the terrain is endless, and we have 3D noise caves. They look pretty nice. These are the caves. And we have a bunch of mobs. Cow, pigs, chickens. And at some point they start playing sounds, idle sounds. So that's pretty much the game. Obviously we have other stuff like here, flint and steel. We have flint and steel, texture animations, texture packs, etc. And so that's kind of a summary. And so for this stream, chat, I was thinking of maybe doing a polish stream because we have lots of stuff to fix. For example, like the most obvious thing to fix is the positioning of the items in the hand. The other thing to fix is the clouds. The other thing to fix is the mobs. We have lots of stuff to fix. So I've decided today we'll be doing a polishing stream. Polishing stream. We'll be polishing the game, chat, today. Yo, what's up, man? What's up? What's up? How have you been? Let's list out the things we need to fix in this polishing stream. So one thing we need to fix, infinite clouds, 3D clouds, items to position and scale items properly. I am not going to be here for long because I'll go to the beach. Man. Yeah, some people are on a vacation, it seems. I don't have a beach where I'm at. What else can we fix? Animations. We can try to do animations. So for mobs and Steve. Crafting recipes. We can finally do crafting because we have items. Also, mob interactions to hit mobs and mobs hit player. Mob interactions. Fix villages because we disabled them. And what else, chat? What else? Block breaking animation. This is also needs to be done. Day night, maybe not right now. So I was thinking, let me think about it. Let's attempt to do 3D clouds, chat. Let's attempt to do 3D clouds, and then we'll attempt to properly position the items, chat. Let's attempt to do clouds, chat. Because the reason we ignored the clouds was because we couldn't read the pixels from images, but now we can. So we should have everything we need to create clouds. Yeah, let's start the game again. And so we'll create a 30-minute timer just in case. We'll do a 30-minute timer. Can't we use the algorithm for making item mesh to make the cloud mesh? Maybe. Maybe. We don't need to currently. We want a simple approach. And the simplest approach will just create a simple cube for all of the cloud positions. And but it needs yeah, it needs to be 12 by 12. It needs to be 12 by 12, but the height should be different. Yeah. We're using Krelip, chat. We're using Krelip. So currently these are my clouds. They're simple 2D clouds. And they're not actually endless. So look at how they stop up to here, chat. They're not endless. But if we open Minecraft, here. In Minecraft, they are endless, the clouds, and not only that, but if we enable 3D clouds, where is the option for 3D clouds? Here. Yeah, and this is the 3D clouds, chat. So we'll do something like this, where actually we figured it out from previous streams. The clouds look like this, chat. Minecraft raised them probably from this image, this pixel art, where each pixel is one cloud. Each pixel is one cloud, and we calculated that one pixel should be probably 12 by 12 in the game world. So 12 blocks by 12 blocks should be one cloud. For example, this one. This is one cloud. This is one pixel from the image. This one. This is one pixel from the image. And so basically, should be very simple. We'll go over all of the pixels, and for each one of them, we'll render a mesh like this one. That's what we're going to do, chat. And we should be able to have 3D clouds. And that's extremely important to have 3D clouds because the difference is huge. It looks a lot better when they're 3D clouds. And we'll attempt to do it. We have 30-minute timer, and we've started it already. So we have 27-minute timer. And so let's do this, chat. Let's do this. Let's do this, chat. So this is the current version. This is the current version. They're just simple clouds. Where my current implementation is just I used Perle noise. I sent the data to the shader, and inside of a fragment shader, we just went through all of the pixels, and if they're above 0 or 0.5, I make them the white color. Else, I discard them. So we generated this through a Perle noise. Instead of that, we'll go over this texture. This is what we're going to do. And we already have it in the game. From a previous attempt, we already have this texture in the game. We just need to go through it. And so that's what we're going to do. So let me find where in the code we're going to go through the image. Let's decide where we're going to do that. We don't have settings yet, chat. We attempted to add settings, but we failed. We failed to add settings. So where are we going to go through the clouds? Let's do it here on a touch, chat. Let's do it here. This code gets executed when the world gets generated. So when the world gets generated, we'll load the clouds image here. This is the clouds image. And we'll just use the relib function called load image. And for the path, we'll use resource path, which is just, it makes it so it's easier to find the path. It automatically gets replaced with my D drive, the parent folders. It's the absolute path. So here I can just use like textures, clouds, PNG, something like that. but we need to confirm because we'll crash the game if it doesn't exist. So in resources, textures, clouds. Okay, yeah, so this is the folder. Yeah, this is the folder. And we've already done something like this when we converted the pixel art to a 3D mesh. We already, because right now, in order to process this image, we need to go over pixel by pixel. In order to do that, we need to execute some code, which we can just copy paste from the way we generated items. And where did we generate items? Probably here. Yeah, here. Yeah, it's here. Yeah, this is how we go through them. This is how we go through the values. Let me think about it, chat. Do not donate. Bro, don't donate. Don't worry about that. Just watching and chatting is plenty. You should make a Minecraft clone game engine so that like random people will be publishing Minecraft clones and Microsoft won't know where they got the code. So you're suggesting I should make an engine and distribute the engine so it's easy for everybody to make a Minecraft clone. Well, I can tell you there already exists something like that, and it will be 100 times better than whatever I do. There's already an engine for making Minecraft clones, and even Vintage Story uses it. This voxel game that's very popular, Vintage Story, if you search for its engine, you find this Manic Digger GitHub. This is an open source engine, chat. This is it, Manic Digger, multiplayer block building voxel game, Minecraft clone. And this is in C#. This is an engine you can use, and it already has multiplayer, it has survival, it has everything you want to build a voxel game. And this is how Vintage Story came to be. The developer used this project. So there's already something like what you're suggesting. I don't need to build an engine and publish it. There's already something that exists. And it's pretty cool, chat. Pretty cool. But I haven't gone through it. Okay, and we're wasting time, chat. Our 30 minutes are about to end, chat. Let's lock in. So for the clouds, we'll go over every pixel, and for each pixel we'll create a cube, but we need to combine all of the cubes. We need to combine all of them. And how are we going to do that? Because in order to create a cube, we need data for each one of the vertices. And that's a bit of a problem because it's annoying to set up. And Relic offers a function for that called generate mesh cube, like this. Generate a mesh cube. The problem is it's just a single mesh. Each cube will be an individual mesh. We don't want that. We want to draw them in a single draw call. All of them. All of the clouds in a single draw call. And chat already suggested we could just reuse the system we built for generating from pixel art the items. Chat already suggested to do something like that, like here. This was pixel art, and we created these 3D items by creating the little cubes for each pixel. The problem is they have a limit of up to 1 block. They are quite limited. So this the system we used for this generation is the same one we use for the terrain generation. It's absolutely the same one. So it would be cool if we manage to use it not only for the terrain, not only for item generation, but for the clouds as well. It would be awesome. But is it possible? Is it possible? That's the question. Let's do an attempt. Let's do an attempt. Let's try it. Let's see what happens. Let's use the system for generating the terrain to generate the clouds. Let's try to do that. I think that would be interesting. Yeah, let's just copy paste it, chat. Let's copy paste it. Yeah, here. Copy paste it. Actually, we'll copy paste all of this. We'll copy paste all of this. And so in the code where we handle the clouds, we'll do it here. Image like this, and here like this. So here we set up clouds. Here is where we set up the clouds. But there is one issue. How are we going to move the clouds? That's what I'm not sure about. How are we going to move them? Because if we generate the mesh will be static. It will be in a single place. Okay, that's a future problem. We don't care about future problems. Let's just focus on the next problem. So here, this is if we cannot load the cloud's image. We want an error if we cannot load it. So, and we check the image format if it's this format, RGB A. So red, green, blue, and alpha. And all of them should be 8 bits per value, probably. Translating the model by the negative x-axis. Yeah, but the clouds will... Okay, we can easily move the whole model. We can easily move it. The problem is if the player stays in one place, or even worse, goes in the opposite direction, you need to continue generating clouds. So are we going to generate clouds every frame? Or like every tick, 20 ticks per second to generate them? But that's a future problem. That's a future problem. And chat, I've made an upgrade to the standing and sitting down. Now the camera, I don't need to touch it. Bam! I didn't touch the camera. It's the same camera for sitting down. That's a big improvement from previous streams, chat. So let me think about it, chat. Let me think about it. How are we going to approach the clouds? How are we going to do it? This is for culling. A big mistake we did when we tried to convert like a pixel art to 3D mesh. The biggest mistake we did was trying to optimize it, to do it in the first try. That's a big mistake. Let's not do culling in the first attempt. As of now, we don't care about the culling. Minecraft generates clouds from procedural noise. Then what's this image? What's this image, chat? If it uses procedural noise. Doesn't it use this texture where each pixel is one cloud, chat? We'll just use this image. We don't care about doing procedural noise. We'll just use a simple image. We'll keep it simple. Not that big of a deal. So for culling, let's ignore culling. And let's create, we need a mesh context. There is no culling like in mesh generation. So you're saying there's no culling, but if we go into the clouds, I'll show you. I think there is, probably. Let's see. I'm not sure. Okay, there is not. Okay, perfect. There is not. Okay, there's no culling. We can easily do culling, chat, if we want. We can easily do culling. Probably they do it on purpose. Like they can easily have culling. They could easily have culling. Chat is saying there's a creeper face in the clouds. Where is the creeper face, chat? I don't see creeper face. Where is it? This is my face. I added this one. This smiley face is from me. I added this one. Down. Yeah, I'm down here. Where is the creeper face? Okay, chat. For generating the clouds, how are we going to approach this? We'll attempt to use the same approach like the item generation. So we are going over all of the pixels. We're going over all of the pixels. We don't care about these visible pixels. We don't care about this. This was for culling. This was for culling. We don't care about this. Here we get the red value, the green color, the blue color, and the alpha. Let's actually check out the image ourselves and see. Okay, it's just 1 for all of the values. Else, it's 0. Okay, we just need the alpha. We don't care about the color. We'll just get the alpha, chat. Here, we just care about the alpha. And we don't even need to divide it by 255. We don't care about that. This will improve it to make it faster to generate. And here we create how are we going to do this? If alpha is above 0, we'll create a cube. If alpha is above 0, sure. And here, this will be from 0 to 16. From 0 to 16. This is a full block. This is in pixels. This should be a full block. For now, we'll keep it simple. Each cloud from the pixel art will be 1 block in game. It will be 1 block. We'll try to scale it up later. For colors, we don't care about the colors. There will be just white. Yeah. So here it will be 1, 1, 1, and the alpha 1. This will be the color by default. Texture origin 0, we don't care about that. So for culling, we will not cull anything. We will not be culling anything. We will not be culling anything. It will be a full cube. Sure. And what now? We need cube mesh pool generate and what now, chat? Let me think about the chat. Right now we are generating for each pixel a cube. Okay, that's perfect. But we need to store the information, and I'll just copy paste the way we did it from other times. Here, generate, then we get the data and we append context. Here, like this, chat. We'll be allocating all of the vertices into a single place, chat. Into a single place. Here. And we need a mesh context. This is where we'll store all of the vertices. We need a mesh context. Mesh context, and we append the data into it. Very simple. Very simple. And what's next? And then we need to get the mesh. We get the mesh from the mesh context by generating it. We upload the mesh. We create the model. We set up a shader. And then what? Okay, and this should be the actual model for, and this will do it for the whole texture. We aren't doing any limits. We're doing the whole texture. We need to do some kind of limits because this will be huge in Minecraft world size. So in Minecraft world size, this would be 256 by 12. It will be 3000 by 3000. Wait, that isn't that much. 3000 by 3000. How much is one world? Minecraft render distance in blocks. How far is 12 chunks? 200 blocks is 12 chunks. Okay, so it's enough. It's 3000 by 3000. Enough. Okay. So what now? Oh, for a position. We need to update here a positioning. We need positions here. For the position, we'll do here the X. The Y will be for the Z. Like this. And the model itself, we need to save it. We'll save it here somewhere. We'll save it here. Model. Clouds. Just clouds. So here we do clouds. Is this. Here clouds. Like this. So we should have clouds, chat. We need to render them. To render them, we'll render them here after the player. We'll do draw model, clouds, position will be 0, 150, 0. And scale will be 1. Oh, bro, we can just scale them by 12 here. It's fine if they're 1 block big. We can just scale them from here. Oh, this makes it a lot simpler. This is why we don't worry about future problems. Some of them get automatically solved. But we'll see. No, this is not more optimized than actual Minecraft. I can bet you that. Minecraft gets a lot better FPS. Here, look at this. Minecraft is like, how much? We've put a limit, I think, on the FPS. Yeah, we've put a limit. We have VSync even. Unlimited. Did I save it? I didn't. Why? Minecraft is, look at this, 500 FPS. My clone has never gotten 500. My clone is maximum 200 FPS. Like my clone is not optimized. And here this game has a lot more features than my game. Video settings. Let's remove this. Yeah, 120. Yeah, it's not vanilla, of course. Vanilla will be even more FPS probably. Can get below 80 on most devices. No. Like chat, did you see the chat? I'll open Task Manager. Look at the performance here. Look at the graphics card is good, the CPU is good, the RAM is good. So like the game does a lot better than my project. Chat here, white like this. Let's draw the model. Let's draw the clouds. This should be it, chat. We should be having simple clouds. Hmm. Why are they so limited? Why are they here in a straight line? Why are they in a straight line, chat? Pretty good, but don't get me wrong, but there's some kind of a limit we've set. Some kind of a limit that we're using. Oh, and let's move them B where the color blend is. Where the color blend is. Where did we set up the clouds? Yeah, here. Did we do a limit? Did we have some kind of a limit here? Yeah, the Y is the whole image height. The X is the image height as well. And positioning is the X and Y. Let's look at the generate and local block. Yeah, it should be. What's the problem, chat? What's the problem, chat? Why is it limited so much? How many pixels on the... Is this the width or the height? This is the X direction. The X doesn't have a limit, the Z has a limit. And it starts from 0, 0. Yeah, this is 0, 0. So towards the Z, it has a limit. Towards the X, it looks to be fine. Yeah, but image dimensions are 256 by 256. So let's look at the X. Look at this, chat. The X is 256. Yeah, the X is fine. The Z is limited to around 50. The Z has a limit of 50. Oh, I know why, chat. I know why. It's because of the it's limit of the vertices, chat. We've hit the limit for the drawing. It just stops here, chat. It stops here. Yeah, there's a limit to the probably the indices. Yeah, it's just a limit. It should be fine, chat. It should be fine. Let's do. We need to have our own limit here when we read the image. When we read the image, let's read 50 by 50. Let's read here. Let's do rectangle. Limits. We'll call it limits. And it will be from 0, 0 to 50, 50. And here it will start from... Will it? It will not start... no. From here, we cannot change it. Because here we just use a different variable to iterate. Now let's just have the limits here, chat. Let's just have the limits here. The Y, the... How is this, chat? Let's do Y plus limits height. And here let's do limits X plus limits width. Like this. We are limiting it to be 50 by 50. Yeah, okay, chat. This is 50 by 50 clouds. 50 by 50. And wait, is it correct? Let's do some kind of a screenshot, chat. Is it correct? This is 50 pixels by 50 pixels. So 15 by 50. And let's look at, we'll compare We'll compare with the aspirate. Okay, it should start probably from here. Let's get a 50 by 50 region. This is a 50 by 50 region. It's not this for sure. Yeah, look at this, it's different. It's not this. Maybe it starts from the bottom. Yeah, here probably. Does it start from here? 50 by 50? Yeah, it's probably not this as well. Does it start here? No, it's not this. And it doesn't start from here. Okay, we're not reading it properly. It'll look probably better if you scale it up. We're not scaling it up as of now. I want to be sure we're reading it correctly. Here we're making some kind of a mistake. We're doing some kind of a mistake. What's the mistake? What's the mistake? Oh, I know what's the mistake, chat. Yeah, it's because here, yeah, when the way we iterate the array of pixels is one dimensional. It's one dimensional, and so it continues to go forward on the x-axis. The x-axis is 256 pixels, but we limit the x-axis in our case to be 50. And so like we have a slight issue. We need to do it a bit differently, chat. We need to do it a bit differently. We need to do it a bit different. So here, instead of this k, we need to do something else. We need to calculate it from here, int index. We need to calculate it from the x and y. That's what we want. That's what we need. How are we going to do that? Well, it's not only one dimensional, but each element is a separate color. So like for the first pixel, it's on the first pixel. Okay, so x equals 0 and y equals 0. It will be for index between 0, 1, 2, and 3. Because this will be the red, green, blue, and alpha. And then for x equals 1, y equals 0, it will be 4, 5, like this, chat. To just update k before x loop starts. How are we going to calculate this? So when it's 0, 0, we will start from 0. If it's 1, 0, we'll start from 4. Right? So it's like, oh, no. So it's x times 4. X plus y times 256. The image width. The image width. Let's try this. Let's do an experiment. Let's try this. Wait. Times 4. So the whole thing times 4. The whole thing times 4. Like this. Yeah, this should be it, chat. So here we use index plus 3. We use index plus 3. Let's test it out. This should read it properly. Okay, this is much better. Much easier to believe. This is much easier to believe. So this is the x, z. Okay, let's look at it like this, chat. look at it like this. So, and let me open the aspirate. Yeah, I think we got the. I think we got it. I think we got it. Chat. Think, yeah, look at this. It's 1-to-1. 1-to-1 chat. Look at here this, and here this chat. Here this one, and this one. This, and this. This, and this. 1-to-1. Okay, perfect chat. Perfect. Okay, now we can scale it. Now we can scale them. Okay, let's scale them. Bro, are we... Is it this simple and quick to add 3D clouds? So, when we draw them, we'll scale them by 12. Let's scale them by 12. Do that. And let's make them the height. Let's change the height. The height to be smaller. And let's change the shader. We'll use the clouds shader. Okay, for the height, we'll do 1 pixel here. 1 pixel height. And for shader, we'll use the clouds shader chat. Non-uniform scale. X, Y, but not Z. Oh yeah, we can do that. Non-uniform scale. We could do that. Ah, look at these are clouds, chat. Clouds. 3D clouds, but they're too thin. We need to make them bigger. Bro, why is it so fast, man? Like, we just started this and we already have kind of clouds. Okay, let's do the scale to not be on the Y. Here, we'll leave the height to be a 1 cube, but when we draw them, when we draw the clouds we'll do draw model EX clouds position, and let's disable the old clouds. Where did we draw the old clouds? I'm not sure where we drew them. Where did we draw the old clouds? Cloud model, brother. Yeah, here is where we drew them. Oh, just below where we're currently doing it. So we'll remove the old clouds. We'll remove the old clouds. The Y value will be the max block height. And then rotation axis, we don't care about that. Rotation angle 0. Scale. Now for the scale. We'll scale it 12 and 12 on the X and Z. and no color overlay. Let's test it out. And actually I want to test out something. What do they use? For rotation axis, they use this as a default. Test it out. These are the clouds. Oh, wait a minute. What are these clouds? Are these our clouds? Are these the new clouds? Yeah, clouds. Oh, here needs to be 1. Yeah, sorry, chat. The y-axis needs to be 1. We did 0 and it crushed the y-axis. Okay, yeah, 3D. 3D, but maybe to scale the y 2 times. Maybe the y-axis to be 2 times. Is it like this? Let me go here. Bro, here is much better, chat. We are still far off. So for the clouds, we could... Yeah, let's make them easier to see. We need to change it in the shader. Shaders. Shader. Clouds. We don't care about discarding. We don't have something like that. Wait a minute. Wait a minute. Let me think about it. Let me think about it. This needs to be renamed. Rename. This needs to be this. So we have syntax coloring. And in the game layer, here, clouds, this needs to be like this. Okay, so now we have syntax highlighting. It's easier to see. Here we're using a texture. We don't... Should be white color texture. It should be. We don't care about discarding colors. We don't care about that. Yeah, it will be... No, we could... Let me look at the default shader. I want to see a default shader. Yeah, this is default shader. Yes. I don't care about this. This was for discarding pixels. We don't discard pixels. Like this. In here. Let's quickly test it out. Okay, yeah, we removed the alpha. We removed the alpha. And now maybe we could use the normals to make them look like in Minecraft. Using the normals to make them look like Minecraft. Because on the sides, 4 blocks high. Okay, we'll do 4 blocks. But what about the colors, chat? What about the colors? Let's just make it slightly less of an alpha. Maybe. Or to play around with the positioning. To play around with the positioning. And we need to make them bigger. Like maybe 100 by 100. Let's do here. Here, let's do 100 by 100 of the pixel. And here for set color, the alpha will be 0.8. Let's say 0.8. And when we draw them, clouds. When we draw the clouds, we need to scale by 4 for the Y. For the Y. And let's test it out. How's the transparency? Is it it's not this. It's not using the alpha for some reason. Not using the alpha. Yeah, we doubled the height, chat. The height is 4 blocks. Height is 4 blocks. And the width, the dimensions are 100 by 100 pixels of the texture. So what now? We could, one option is to focus on the colors. Second option is to focus on to make it dynamic, to move the clouds, to continue to generate them. That's the other option, chat. No, the other ones should be ones because they are just, oh, so you're saying to make them grayscale if they're all of them 0.5s, like to not be clear white. Let's try to make them move. For the coloring, it's not a priority because if we have the coloring by the end of the stream, it's not enough. We'll have to scrap it because they need to be functional. But if we have if they're like this, without the coloring, without proper coloring, but they generate, they're endless, they move on their own, we'll keep the feature. So that's a priority. So let's focus on that. Let's focus on movement and to make them endless. Because right now, they are quite limited. Yeah, here they stop. Here they stop. We don't have clouds here. How are we going to approach this, chat? How are we going to approach this? Let me change the stream thumbnail. Done. This should be done. Yeah, it should be changed. Change. And this done. Save. Now it's done. We have the new clouds in the thumbnail. So about the movement, chat, let's open up Minecraft as reference. The colors are not, we don't have proper colors, but it's not the priority as of now. Not the priority. The priority is the movement. Priority is the movement. Look at how on their own they move. They move on their own. If we put tick and freeze. Do they move? They should be moving. Yeah, look at this, chat. They're slowly moving. They're slowly moving, chat. The clouds. We need to implement the slow movement. Not only that, but they need to be endless. So look at here how, no matter how much you travel, the clouds are endless. You always have clouds. This is what we want, chat. This is the goal. Yo, terrain generation is pretty good in terms of speed. This is what we want. How are we going to achieve this? Because the way we do it, the way, bro, it's a big difference going from Minecraft to here. The way we do it is we go over this pixel art. We go over this pixel art. And for each pixel, we create a cube. And we scale up the cube 12 by 12 by 4. Like 12 by 4 by 12. X, Y, Z. The problem is we're just using one region of the texture. We start from here. We start from this region, 100 by 100 region. We do here 100 by 100. The problem is, this is the problem. Let's say we follow the movement of the, how are we going to, bro, it's not simple, man. Okay, let's just have the clouds be static, but endless. This is something easier to do. Let's have them be static. And so how are we going to have them be endless? Chat, is this texture endless? If we think about it, is this endless? Probably. They're just clouds. Who would care about clouds being properly endless? Let's assume they're endless. Minecraft, it wraps around. Okay, and let's say here, chat, we'll create a new layer. Look at this. I'll visualize it. We'll create a new layer here, and it will be bro, how to create a rectangle. Okay, let's say this is it. Say this is it. This is our region. Let's change the color. Can I change the color, chat? It's very annoying. Bro, it just uses the white color. How can I add a new color? Oh, like this. Finally. And let's change the opacity. Just so we can visualize the region. Okay, chat. This is what my current struggle is. Let's say we start from here, chat. We're not using Perle noise. We'll just use this PNG. How are we going to do this, chat? Because the problem is, let's say it follow the clouds are endless like this. Let's say this is our camera and we're just going through them. This is our camera and we go through them. The problem is what happens when we reach here. I think it needs to wrap around like this. If it's here, let's duplicate the layer. If it's here, it needs to continue here like this, chat. I think this is what we need. So if it's here, it needs to be, the other end needs to be here, to continue here. And like this, it will be endless. It will be endless like this one. Use the new texture. What do you mean by a new texture? This one is fine. We can just use this one. I don't want to waste time trying to find a different texture where we can already use this one. We are on a tight budget, chat. Let me think about it. How are we going to do this? This wrapping around. Okay, so we just need to change the start and the end. That's the only thing we need to change. I doubt users will notice the wrapping. It doesn't matter. Like, because it's for us, it's not for the user, the wrapping. It's for us, because the texture has limit. It's 256 by 256. We have a limit. We have to wrap. There's no way around it. We have to wrap. We need to wrap from here, and so at some point we'll continue here. And the other piece is gone. And we'll continue. And if we're here, we just teleport. We just teleport here. And we continue here. Like, this is what I mean. This is what I mean. Copy and paste it 8 times. Make it one big square. Then move the whole texture. To move the texture itself. No, it's fine. Use climate map image. What do you mean climate map? I'm not sure what that is. Chat, we'll do this approach. And let's synchronize it with the player position. Let's synchronize it with the player position. We'll do a radius of 50 blocks around the player. And we'll calculate, we'll map the player position onto the texture. How texture could be procedurally generated. Okay, let's say here is the player, chat. Let's say here is the player, and we need to calculate the region around the player. The problem is the left side, the start point is right here, chat. This is the start point. Oh yeah, we just need to calculate this starting point. That's what we need. We need to calculate this starting point. And from there, we'll just increase the coordinates. And when we reach the limit, we'll just wrap around. We just need to calculate, given a player position, to calculate the starting point. That's what we need. And from there on, we'll continue. Okay, so how do we get that? Let's say, and we'll use just the player X and Z coordinates. We'll just use the X and Z coordinates. So you're saying the position? No, this is the cloud mesh position that you're talking about. We're not focusing on the cloud mesh. We are generating the cloud mesh. But there's another problem, chat. Oh no, wait a minute. There's another problem. The other problem is let me think about it. We could actually just render. We could render all of the, like we could render the whole thing with multiple draw calls. We could render the whole thing with multiple draw calls, which will be a huge cloud system. And using frustum culling, we just render the clouds, the chunks of clouds that are visible. Yeah, we can use the frustum culling to just render what we need so that we don't need to constantly generate stuff. so that we don't need to constantly generate. So we'll have lots of clouds around the player, but at some point they will end. They need to be repeatable. At some point they will end. Oh, okay, that's the idea, chat. That's the idea. So no, it's very simple actually. It will use let's just assume like this, chat. We'll do it like this. Look at this, chat. Like this, bam, but in game. Not the texture stays the same. The logic will be like this. Like this. Let's say like the canvas is infinite and we'll just be repeating this region everywhere. We just need to handle when are we rendering. It will be the same logic as the terrain, chat. It will be the same logic as the terrain generation. It will be just huge spread out chunks of clouds. Yeah, I have an idea. I have an idea, chat. I have an idea. Yeah, I have an idea. I just need to think about it. I just need to think about it. It will be just like having chunks. It will be just like having chunks here. It will be like... Bro, where is the... Yeah, it will be like this, chat. It will be like this with chunks. It will be like chunks. And let's say the texture starts from here, chat. Let's say texture starts from here. We'll render just the visible ones from here onwards. And we are going through the texture, through the chunks. And at some point, we reach the end of the texture. But that's not a problem. We just start over from the other side. And actually, we may be able to do it by 16 by 16 pixels. It's 256 divided by 16. Okay, we can do 16 by 16 chunks. Yeah, because if the regions are 16 by 16, so it's just 16 by 16 pixels here, like this. Oh, it's actually here, just the grid, like this. Oh, yeah. It will be this here. And then here, all of these regions, let's say all of these ones are separate chunks. And when the algorithm requests a chunk here, when it requests a chunk here outside of the texture, it will just get it from here. It will just get it from here. Okay, we'll do it like this. I have an idea. Okay, chat, let's lock in and let's do it. Let's do chunks, chat. Let's do chunks like this. Yeah, let's do it, chat. Let's do it. But how are we going to approach it, chat? How are we going to approach it? So chunking for clouds. That's a bit of an issue, since it was a big struggle dealing with having endless terrain. And now we need to have endless clouds. Chunking will be annoying because here, chat, having the terrain be endless, this was a big struggle, chat. This was very annoying because I don't do multi-threading. Probably with multi-threading is even more complicated. I do it in a single thread. And if we try to do the clouds using chunks, it'll be a bit of a problem, I think. We could no. Actually, we can do it in a. The reason it's a problem having the terrain be endless. The reason it's a problem is because you get lag spikes. It takes a lot of time to generate everything. But with the clouds, it's different. With the clouds, it doesn't take a lot of the performance because we'll just generate all of the chunks once, the models. We'll generate the models, and when a chunk requests a model, he'll just get it from the pre-generated ones. It will be instant. It will be instant. Okay, I have decided, chat. I have decided. Chat, I don't read every message because most messages are very long and currently we're just brainstorming. The shorter ones I read. Like the please listen one, the hi, I read. The long paragraphs, I cannot read. Clouds needs alpha. Yeah, you must have joined recently. Hello world. Okay, chat, let's do this. Let's do this. Yeah, so when we generate them, we'll have them here. Look at this. Where is it? Game layer. Game layer. So in the game layer, instead of having a single clouds model, we'll have 16 by 16 clouds models, and we'll be reusing them. That's my idea. Hi, Petsa, what's up? And how are we, in what data structure are we going to store them? Chat. How are we going to actually get them? An unordered map, probably, a hash map, probably. So for easier, no, a 2D array. A 2D array of models. Probably. Yeah, we can do model clouds, and here 2D. It can be one dimensional as well. It can be 16 by 16, like this, chat. It can be like this. These are the, oh, we need to do a commit, chat. Let's do a commit. Let's do a commit. Does it run? We'll do a commit. Okay, it runs. Let's do a commit. Let's do a commit, chat. Here, we render 3D clouds from a region of a texture. That's what we did. And so now, instead of a single cloud, we'll have a 2D array of cloud models, which are 16 by 16, and we'll reuse them. I think it's cleaner, simpler to keep the cloud models relative to one another. If there's global tick chat, I'm not taking a lot of suggestions from chat. If you have preferences, you can do them when you guys make your work on your projects. Here, I avoid taking much suggestions from chat because like it defeats the purpose of this project. Like the goal here is not to create a cool project. The goal is for me to learn how to make one. Okay, chat. Here, this is what I've decided to do. We have 2D array of cloud models. So now when we go through the texture, we'll go through the entire texture. We'll go through the entire texture here. The entire texture. Sure. Yeah. And so we can do it like we did it before. Here we'll do k equals 0. We don't need an index. We'll do k plus equals 4. And here we'll do k like this. And here we'll do the image. We'll do the image height. We'll do the image width like this. And now we need to at some point stop, generate a mesh, store it, and then continue on. That's what we need to do. That's what we want. And when do we do that? When do we do that? At 0, 0, here we can store the limits, how much a chunk is, a cloud chunk size in terms of pixels. We can do vector2 size, and it will be 16 by 16, like this. And so chat, now how are we going to know that we are outside of this limit? We can track them here with integers here. We can do current chunk x equals 0, like local x. Local x equals 0. Local y equals 0. And here local y plus plus. Here local x plus plus. Like this. And when they become 16, we reset. That's my idea. Yeah, here we can do it before all of this probably. So they are 15, and at 16 we need to reset them. Here if. Oh, but this is an issue, chat. This is an issue. This is an issue because of the way we go through the pixel art. Because we go through the entire image width. We go through the entire image width. Yeah, we'll change it. We'll change it. We'll do it in a while loop. Probably. Because here we need to go through a 16 by 16 region and then switch to another one. Okay, so how many regions are there? We'll iterate the regions. We'll do a 2D iteration of regions. And we have to bring up the index. Yeah, here we'll bring back the index like this. And so here we need to do for int chunk x equals 0, chunk x less than, and how much is the let's start with y, with the y chat. So b, if it's less than image height divided by size y, like this chat, and chunk y plus plus. And then we do the same for the x. We do the same for the x, like this. Like this. And so now for one chunk, what do we do, chat? For a single chunk, what do we do? More for loops, maybe? Brother. It's not that big of a deal if we do, again, 2 for loops. Because the actual iteration is, again, the same count. It's the same count, even if it's 4 for loops. It's just a different way we're going through them. Like this. We paste it here. And we do this, like that. Bro, 4 for loops, man. 10 billion for loops. brother. We don't need this. We don't need the local positions. We don't care about that. But here, for the y and x, we need something else. For the y, we do chunk y as a start. Chunk y as a start. And then we do, if it's less than, the chunk y plus size y. And here we do chunk x, if it's less than, chunk x plus size x, like this. We calculate the index, we get the alpha, and everything else is the same. And what next? And then, yeah, we generate, damn. What do we do next, chat? Sure, here. Where is the mesh? Here is a mesh context. After all of this is done, we need to clear the mesh context. Clear. We need to clear it. And here for clouds, we'll do clouds, chunk y, chunk x, and we save it there. And the same for the setting the material. Chunk y, chunk x, like this, chat. That should be it. We should have everything, chat. We should have everything. And so what's next now? What's next? We could temporarily just draw all of them just to test them out, right? Yeah, let's try to draw them. Draw model EX. Yeah, here. Here we need to what? We need here to go over all of them. So we'll do for int chunk x equals 0, chunk x less than 16, chunk x plus plus. We need to do the y as well. We need to do the y. And for all of them, we'll draw the cloud. Chunk y, chunk x. And here for the x and z, we'll do chunk x. And here, chunk y as floats. And here as a float. But this is for the coordinates of the mesh. It needs to be... needs to be... We need to use both the scale. Here, let's do vector to size. Let's do size. It's 16 by 16. And here, vector to scale equals... It's a vector 3, but we don't care about the y. It's 12 by 12. And so here we do... This is the scale x. This is the scale y. And here for the position, we need to multiply by size x and by scale x. And here by size y, scale y. Yeah, something like that. Okay, so now we should have all of the clouds, like from the whole texture. What's the issue here? Generate mesh. What's the issue here? Oh, we unload the image. That's the issue. We unloaded the image. We'll unload it here. We'll unload it here, chat. Okay, done. So do we have everything? Or I think they repeat. Yeah, they're repeating. All of them are repeating for some reason. All of them are repeating. Oh, because here when we draw them. Wait, why are they repeat? Oh no, when we draw them. When we draw them, draw model EX here. Yeah, we are going through all of them. Why are they the same, all of them? All of them are the same. Why are they the same, chat? Why are they the same? Like all of them go through the same region for some reason. And that's... Oh, wait a minute. Why is chunk Y going through the entire image height? That's a big mistake. This is 16 and this is 16. Oh, we divided by the size. It's fine. It's fine. It's fine. And then here we go over the Y and X. Sure. Sure. And then we calculate the index based on the X and Y. The image width was fine. We get the alpha, that's fine. We calculate this. We generate. Sure. We get the data, we append it to the mesh context. We generate the mesh, we upload the mesh, we save it, and we clear the context, and we do it again. But all of the cloud models look to be the same. Yeah, look at this. They repeat, chat. Look at this. Here, this is the same as this. And it's the same as this. It's the same as this, as this. Do they end at some point? They should end. Yeah, they end here. They end here, chat. What kind of test can we do, chat? What kind of test can we do? What's the problem, chat? What's the problem? Yeah, we go over all of the cloud chunks. And for each one, we call the draw model function. And we actually go through different ones. So all of the different... Okay, breakpoint. Let's do breakpoint. Try to make each image in different position, each cloud. We should be doing that already. We should be doing that already. Yeah, clouds. Clouds, what elements does it have? Yeah, they look to be different. They look to be different. Okay, this is one array, and inside of it, another array. And each one has a different mesh. Mesh count, meshes. Vertex count. Okay, this one has 3168. This one has... Okay, they have different vertex counts, so they are different. They actually are different. We are not dynamically generating them. We are using from a pixel art. Could assign each model. Oh, yeah. That's a good idea. We can do that. That's a good idea. Yeah, here for the color. Color. Can we do it like this? In here, The numbers are between 0 and 16. If we multiply, yeah, we can do chunk x, chunk y, 255, and here by 16, So this should change the colors. Let's remove the breakpoint. Do colors change, or am I actually using the colors? Maybe we're not using colors, these colors. Let's do here a red, just in case. A red for all of them, just to check it. No, it's not using the color tint. It's not using it. We need to check the shader. Color diffuse. So in the clouds here, oh yeah, we use color diffuse, this one. I don't see any other unit. Maybe it comes from the vertex shader actually. No, it should be uniform. Fragment fog color, no. View position, no. Oh, wait a minute. Pixel color. Oh, frag color here. Let's have it be here, chat. Let's have it be here. Okay, this should do it. Okay, it didn't. Wait, it's a bit different, chat. Oh yeah. Let's remove it. I'm not sure which uniform it's using for the color overlay. Here in Draw Model EX, let's look at the tint. Here, this is Material Map Diffused. Material Map Diffuse. Color Diffuse, Color Tinted. Yeah, this is the tint. Material Map Diffuse. Yeah, I'm not sure, chat. Okay, what did we do now? Clouds. Our only issue is that we have chunks for the clouds, and each chunk is using the same model. That's our problem, chat. That's the problem we're struggling. And we found another problem where we cannot change the color overlay, which is not that big of a deal. That's not our current issue. It's not that big of a deal. Draw model. We go over all of them. They should be different. We draw them. Positions are different. No rotation, scale, color white. Let's what if we remove the scale? Why are they the same, chat? Why are they the same? To use different rotations. Then it will be wild. We use different rotations. When we did the breakpoint, and we look through the array of all of our cloud models, if we look at the vertex count, it's a different vertex count, so they should be different. Yeah, here vertex count 3168, and another one is 2988. So they have different vertex count. They have different vertex count. So the models, the meshes, they should be different. But when we draw them, it's as if we're drawing the same model. And that's extremely weird. Yeah, they have different vertex count, but they are the same for some reason. Let me look at something else. Let me look at, does it have an ID? Yeah, vertex array ID 64. What about some other one? A vertex array ID 75. They even have different vertex array object. So the vertex count is different. The vertex array object is different. But when we render them, oh, okay, chat. Let's render them. Maybe at some point they become the same. Okay. Let's now do a breakpoint. After we have confirmed they are the same, let's now do a breakpoint. Maybe, and afterwards they become the same. Clouds. So this one has meshes 3240, and this one has a different vertex count. Yeah, they should be still different. Are you sure draw model EX is actually reading different entries in the array and not just the one, for example? I'm pretty sure, because here we have chunk y is 0. Okay, let's continue the breakpoint. Continue. 0, 0. Continue. 0, 0. Okay. No, 0, 1. Continue. 0, 2. Continue. 0, 3. Okay, so we actually go through the entries. We go through different entries and we use them here. Yeah, we use and we hit draw. So this is a very weird bug. This is very weird. I don't have an explanation. That's very weird. Or actually, are they actually the same? Yeah, they look to be all of them the same. They look to be the same. Yeah, they are the same. Were they the same? Were they the same? Were they the same, chat? I'm not sure. Okay, I have an alternative. I have an alternative idea. We'll remove this. We'll copy this code here. This code, and here we'll do it like this, chat. Like this. And here int chunk y equals 0. Int chunk x equals 0. We'll draw one instance, and then we may change it also. We may also change it. Let's do one instance. Okay, this is a single instance. Okay, and it looks like this. Nice. And here, this is one chunk, one cloud chunk. Let's try a different one. Let's do completely different, like 10 by 10. Let's do position 10, 10. Oh, but we changed the actual position here. The actual position, let's keep it here, be 0, 0. Let's have the position be 0, 0. Okay, is this different? Wait a minute. Wait a minute. The position changed. Oh, I know what the problem is. Yeah, it's the positions. The positions needs to be local from 0 to 16. It's the positions, chat. That was the issue. Clouds. Clouds, and here the local positions here, these ones. I want them to be local X, local Y, and let me think about it. Here local X plus plus, local Y plus plus, and we need to reset them. We'll reset them here. Local X equals 0 and local Y equals 0. And so here in the actual position, we'll do local X, local Y. This should do it. Damn, it was very weird. Why is it like this now? Is this correct? Is this correct? Is this correct? Yeah, here let's do the 0, 0. 0, 0. Bro, we were so close, man. We were so close. But at least we have kinda an idea what's the problem. Delete 0 times size. Yeah, but that's for the position of the mesh. It's just 0, 0. Here when y increases, oh, y needs to increase afterwards at the end. Needs to increase here. And x needs to increase here. My bad, guys. My bad. Bro. Oh, come on, man. Like, go give me clouds, man. Work with me. Give me clouds. Let's remove the scale. Let's remove the scale. Let's keep it simple. Let's remove the scale. Here, scale. Let's have the scale be 1, 1. And the y scale to be 1. And size, this is fine. Let's see, chat. Where they strip? We remove the I'm so I'm so annoyed, man. I'm so annoyed. Yeah, we're drawing a single cloud. This is for the positioning. It's 0 and the max block height 0. Yeah, it's the actual mesh. It's the actual mesh the problem. It's the actual mesh the problem. Yeah, here, the actual mesh. Well, we go over all of the chunks. Sure, that's not the problem. We go over the chunks and we go over the y and the x. That's not the problem. We have local coordinates. That's not a problem. We calculate the index. That's not a problem. We get the alpha from the image using the index. That's not a problem. And here for each pixel we do a single block. That's not a problem. And here we generate it with local coordinates. Here we use the x, and on the z we use the y, which is exactly what we want. We don't want to touch the y. Then we get the data, we append it to the mesh context, and we increase the x. We increase the x. Here we increase the y. And after we are done with all of that, we generate mesh, upload the mesh, save the mesh, change the shader, and we clear the context. So where is the problem? And here local coordinates, it's between 0 and 16. I think. Yeah. We can do an experiment. Here, breakpoint. Breakpoint will solve the day. Yeah, 0 and local y should be 0. Local block coordinates 0, 0. Local block coordinates 1, 0, 0. And then it's 2. Then it's 3. Bro, why is there a breakpoint here on the clear? So annoying. Then it's 4. 5. 8, 9, 10, 11, 12, 13, 14, 15, and then 16, and the Z is, we need to reset the X. Yeah, we need to reset the X value. That's the issue. My bad, guys, my bad. My bad. We need to update the local X coordinate to not go over 16. We need to reset it to 0. That's what we need to do. We need, where is it? Here. Here we need to do local X equals 0. And it should do the work. It should solve it. Okay, finally. And now let's scale them back. Let's scale them. 12, 12, 4. Yeah, we are resetting the Y as well. We are for sure resetting the Y. Okay, the clouds are now bigger, and now we should be able to pick a random one. Okay, let's change the stream title. It's not a polishing stream, it's 3D clouds. It's not a polishing stream. It's now 3D clouds, brother. Okay, and this should be different. Yeah, okay, so now let's bring back the for loop. Okay, now it should be fine. It should be fine. Is it? It's not. Is it? Bro, why is it still the same? That's very confusing. Wait a minute. Bro, that's very, 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 very confusing. Here, instead of doing this, we'll do 10, 10. We'll draw the same model, but a different one. Let's see if at least they use a different model. Do they use a different model? No, I think even here the models probably. Chat. What's the issue here? We go over all of the chunks. We increase. And here the index. The index, we use the X and the Y, which is fine. Oh, yeah. That's why they repeat. It's because of here the chunks. They need to be multiplied. Yeah. Size. How much? Y. Size X. Size Y. Size X. Okay, so finally we should have clouds, man. Finally we should have them. Yeah, it was just my mistake, chat. Misclick. Okay, so finally we have all of the clouds in there. Finally different, chat. All of the clouds. Finally, chat. Finally. And this is the whole texture. This is the whole texture. And it's not endless. It's not endless, but we have all of the models. We just need to reuse them, chat. We just need to reuse all of the models. Yo, what's up, Wix? How have you been, Wix? Ah, the smiley face cloud. Where is it, chat? I missed it. Ah, this one? No. Doesn't matter, chat. At some point we may see it. Not that big of a deal. So what now, chat? Well, now they are not endless. The clouds are not endless because if we go here, they stop generating here. They end here, chat. Yeah, somewhere here. Yeah, they end here, which is at 0, 0. They end here. We want them to continue, chat. We want them to continue. We'll just reuse other chunks. We'll, like Wix is saying, we'll be wrapping. Like it's we're just copying them over everywhere. So here this needs to, if here we have a cloud chunk, it needs to be the other part of the texture. Like it needs all of this to be copied here. All of these ones to be copied here. How are we going to do this? How are we going to do this? We need to do it. What's the line of textures? This is from a previous stream. This is when we converted pixel art to 3D models. This was for adding items. We have 1 hour, chat. We have 1 hour. Let's make this endless in 1 hour. We'll take the player position. We'll have, let's simplify. Let's have a single cloud chunk and it to be. Let's render the cloud chunk on top of the player. Let's render the cloud chunk on top of the player. And we can do it in game in the main thread. Because we're just reusing existing models. We are not trying to regenerate models. We are not trying to read from the texture. It should be very fast. We don't need multi-threading. We don't need to make it work in multiple frames. We should be able to make it work. Okay, so this was just for testing purposes. We drew the entire texture. Instead of drawing the entire texture, all of the chunks, we'll draw just the chunk. We'll have just one cloud chunk and will be the one on top of the player. And then we'll increase the size. We'll keep it simple. So let's make a commit. Here, what did we do? Render entire clouds texture using chunks. So what now? So now we did this just for testing purposes. We have all of the clouds. We will not be rendering them right now. We don't need to render them. We don't need to render them. So here, draw model EX. Here. No, here. The clouds. We don't need to render them. We don't need to. We'll remove this. We'll have. How are we going to do this? How will a single cloud chunk look like? Well, it needs to have. And think about it. Needs to have. What does it need to have? A single cloud chunk. Let's keep it simple, chat. As simple as possible, just one model. And it will be one. It will be one of these 16 by 16 elements. Like here we can do model cloud chunk. A single cloud chunk. How do we do the endless terrain? I think we use unordered map of the positioning for the terrain itself. What do we do for the terrain? Maybe we could do something similar, where we have a hash map where the input is coordinates and output is a model. We could have that. But the problem is the clouds move on their own, which complicates it a bit. Since the clouds move on their own, if we leave the user like this for forever, if we do tick rate 1000, tick rate 10,000. Tick rate 100,000. No, what's the maximum? 10,000 is the maximum. And so if we leave the player, clouds are not bound to tick rate. No, I didn't. Like, I should have unfrozen it. Like, they're moving. Tick rate is not frozen. So chat is saying clouds are not bound to the tick rate. Okay, let's do tick freeze. Why do they stop moving when we do tick freeze then? Why do they stop moving if they're not bound to the tick update? Chat. What I'm wondering currently, we'll unfreeze them. What I'm wondering is, like, we're trying to think of how we are going to store them. The problem is, let's say the position of all of the models change. Let's say the positions of all of the models change. If the user stays like this, at some point, the chunk will travel a lot of a big distance, and it will be out of reach. How do they accomplish this, chat? How do they achieve this? This is not, let's have them be static. We are once again distracting. That's solved by wrapping. We are distracting ourselves with problems that are far away. Currently, let's just have them be in one place. Tick freeze. Let's have them be like this, static, without moving. We still don't have something like this. We don't have something like this where the clouds are endless. Let's have something like this where they're endless and static. So we need a single cloud chunk, right? We need a position and we need a model. We need a position and a model. Let's do an unordered map. No, if we do unordered map where the key is the cloud position, that's wrong. If we decide to change the cloud position at runtime, this approach will be invalid. We could instead have custom structure that stores a position and a model. And we could have an array of all of the clouds and just iterate through them. No, we could have a simple 2D array. We could have a simple 2D array and to have maybe like we could have for the entire grid position for the entire grid and to change the entire grid position. Maybe. Not sure. There are many. Or if we just store in a 2D array all of the structures where each structure has position and model. If we do this approach and we just iterate through all of them and increase and change each tick update their positions, and if their position is out of bounds, to remove them and replace them with their like new version. And if the player moves, we also update the current ones we can see. The current clouds we can see. So basically, every time when the player moves, we'll go over all of the cloud chunks. And if it's outside of a certain range, we destroy it and we replace it with another chunk, another cloud chunk that's with the proper positioning. The problem is the positioning will be, the problem is with dynamic positioning, it will be difficult to figure out which cloud model to use, because we have two 16 by 16 cloud models. We could have the position be static currently with an ordered map. For the dynamic positioning will be later on. If we have time, it will be today, else it will be separate stream. So for this moment, let's just use an unordered map. And we'll use a vector 2. We'll use a vector 2 as a key. We'll use just a model. We'll use just a model as a value. And here we need subchunk vector, no. Block vector 3 hash. Is there a vector 2 hash? I need a vector 2 hash. Copy paste this chat. We just want to remove the Z. And here in this XOR, we remove this part. Okay, now we have a vector 2 hash. We need a hash for vectors for the unordered map, because else it will not work. And here we'll have clouds. Let's actually rename the clouds here. Clouds cache. Rename it. Clouds cache. Any moment now. Does it still run? Probably. Probably it still runs. Run it. Any moment. Okay, it's still running. We're just not drawing the clouds because I disabled them. Okay, so now we'll use a hash map where the key is positions and the value is the models. This is what we'll use. This is what we'll use, and depending on the player position, we'll update these ones. Depending on the player position. And for the exact model we're using, we will need for the exact model we're using, we will need to do some kind of calculation in order to figure out which model to use from the ones we have already generated. Let's say I'm back. What's up, side mode? What's up? Currently, we're trying to make the clouds endless. We have 3D clouds. We're just trying to make them endless. And how are we going to make them endless? We'll store the current cloud chunks into this hash map. Sure. Let's see where we deal with the current endless terrain. Yeah, here is where we handle the endless terrain. Somewhere here. Yeah, it's here. Is it? Is it here? Should be. Unloading chunks. Yeah, it's here somewhere. Yeah, it's here. If the new subchunk, player subchunk, is different from the last one, or if we're initially generating. This is for the endless terrain. Can't you make the cloud texture repeat indefinitely? I don't... it's a worse approach. Because we went through this entire image and we generated cloud models for the entire image. And we'll be reusing the models themselves. And we separate them into this 16 by 16 grid. We have them into grids. So we have 256 models, cloud models. I think this one is even empty. And so we'll just reuse these models. We'll just reuse these models. I prefer this approach. I prefer this. And it's better to use what I prefer because if I attempt to use a chatter's approach, it's an approach that the chatter feels confident with. It's not an approach I feel confident with, and it will just make the feature worse. Why don't you just use GameMaker? Bro, that was the funniest comment I've received the entire stream. That's the... Yeah, chat, let's switch to GameMaker. I thought use full texture as a model. We cannot use the full texture, chat. We cannot use the full texture because we go over the limit of the vertices. We go over the limit. We don't have enough vertices or indices to use this entire texture. That's why we break it into parts. That's why we break it up. Okay, so here is where we have the endless terrain. And here where we handle the endless terrain, we'll just handle the clouds as well. Why don't you just use PowerPoint? Imagine if we do, I made a Minecraft clone on PowerPoint. I think there is a guy that made Minecraft work on a PDF. Minecraft on PDF. Yeah, I got Minecraft running on PDF. And look at this man. He got Minecraft running on PDF and it's 3,000 views, man. He must have worked so hard on this.
Excited about this, so I decided.
Yeah, here. Minecraft on PDF, chat. He has worked so hard on this and it's like 3,000 views. This is so not worth. But here he has, I have watched his other videos and he has Minecraft on the 3DS, NDS. Yeah, he ports Minecraft onto these handhelds. Like he has very cool videos. Yeah, here, chat. Look at this, chat. This is very cool. And he says he doesn't, he says that he doesn't look at the source code. So like me, he doesn't look at the source code. And he also has redstone working, kind of, I think. So that's cool. That's cool. And look at this, bro. 20,000 views, man. He has spent so much work on this. 20,000 views. Like, this is a lesson that YouTube is not about how cool your project is. It's how you deliver, how you present yourself. Like, you could just make a video on how you go out, how you take a rock on a walk, and if you present it well, it will do 10 times the views probably. Okay, let's not get sidetracked because we don't have that much time. We have 42 minutes left, chat. We have 42 minutes left. So we'll just kind of replicate what we do for the endless terrain. We'll replicate what we do for the endless terrain, but with one difference. With one difference, chat. The difference is we don't need to regenerate the clouds. That's the difference, chat. That's the difference. We don't need to regenerate stuff. We don't need to regenerate terrain, so it should be simple and fast. So how are we going to approach this? Reset subchunk mesh generation queue. Oh, this is for a queue. We don't care about this. Mesh generation data reset. Oh, this is mesh context, right? What's this, chat? Mesh generation data. What is this? Last update offset. Last update offset. I have no idea what mesh generation data is. Do we even use it? Request mesh generation. Bro, I forgot. Oh, it's probably not to have too many requests. Bro, what does she want? We have Pekkat, chat. We have Pekkat. Bro, instantly, site mod on Discord made a screenshot, sent a screenshot just to let everybody in Discord know Pekkat is here. Hello World went to Twitch just to redeem the Pekkat emoji and to use it. 3D scan Pekkat and put the 3D model in the game. Bro. Make a ping when the cat appears on stream. Please add subtitles to make it clear what you're talking about. I think YouTube has a feature like that. Does YouTube have a feature like that for stream? Yeah, but don't, bro, you don't need to spam yourself. He knows both my hands are taken and I cannot stop him. He knows my hands are taken and I cannot mute him. That's why he's spamming now. Okay, the hostage situation is over, chat. Hostage situation is over. Bro, side mode even updated the Discord when the cat is gone. Bro. Okay, chat. We lost a little bit of time, but is it actually lost time? I suppose it's not lost time when it's with Peccat. Okay, chat. For the cloud chunks. How are we going to do that? Wait a minute. Do we need chunks at all? Do we need chunks? We just need... Bro. Am I stupid? Like, do we need chunks? Because we can just... where is it? Here. We have the 2D array of all of the clouds. We have a 2D array. We just need to calculate that which ones from these ones we need to render. We just need to decide which ones do we need to render and what position. That's the only thing we need. And how are we going to calculate that? Well, let's say 0, 0 is 0, 0. And they're like, oh, there's one issue. They're 16 by 16 pixels, but we need to multiply by 12. So they're actually 16 by 12. What the They're 192 by 192 blocks. They're 192 by 192. Yeah, we don't need chunks. We don't need chunks, but we need to figure out the calculations here. Yeah, let's render a single one, chat. The only thing we need to do to render a single one, to render a single cloud model, is we need to decide which one of these we need to render. That's the only thing we need to do, chat. Here, let's do it like this, chat. Let's do it like this. Let's go over where we draw the cloud. Here. And here, instead of a for loop, we'll just draw 0, 0. And here 0, 0. And here clouds cache. Like this. Let's run it. What if you go very far away from spawn in your game? Like, what generation going to be changed, break? We already did something like that. We got the stripe lance. And it's probably because of the hash map hashing. Like how I create from a vector tree the hash itself. Offset entire cloud texture by half. So in 2D perspective, the player would be in the middle. Then just start wrapping. Yeah, I'm thinking of the same thing without offsetting the texture. Like Wix, I'm trying to do the same thing without the offset. Okay, chat, we just have here one single cloud chunk. This is a single cloud chunk. I want here, like this, chat. I want when I go here, this to not render and to render this one. How can we calculate it? Here, this is from 0, 0. And once we reach 100 and something to switch over. Okay, I have an idea, chat. I have an idea. We'll draw here. Let's do it like this, chat. Let's do chunk. Let's do float chunk x equals player position x divided by 192. And we do the same for the y. The same for the y. And if chunk x is greater or equal than 0, and if chunk y greater or equal than 0, this is enough. We'll render here. We'll render. And here we'll render the chunk y, chunk x, and then chunk y. Here, integer. Let's do it like this, chat. This will render a single one, a single cloud chunk. If we are added. Look at this, chat. Hey. Hey. Oh, we're just doing the x. We're just doing the x. Okay, look at this. Okay, look at this, chat. Oh, no, yeah. The clouds update. We just need to now wrap them, chat. We just need to wrap them around. And then once we have wrapping them, because here, if we go here, we don't have clouds. Here we don't have clouds. We need to make them endless to be able to, so here. So when it's here, we need to wrap around from the other position. From the other side, we need to wrap around here. So that it's actually endless. Once we have that, we'll increase the size. Once we have that, we'll increase the size. Wait, why doesn't the Y change? Oh, we need to check the Z, the player Z. We need to check the player Z. Okay, and look at this, chat. We are doing a single cloud chunk, chat. A single cloud chunk that's above the player. From here on out, we can just increase the distance. We can just increase the distance to get much more of them. The only problem is they are not endless. We need to make them endless. We need to make them endless, and we'll make them endless by having some kind of a way to wrap them around. Becca the cat. What? What is the summary on about? Dumb sick. Brother, you'll not be talking like that when they are our overlords. We need get the cloud from clouds texture, but use to wrap. Yeah, we're getting the clouds from the cloud texture. We also have that. We don't need the y-axis. We don't need y-axis. Let me think about it. So this is the situation. This is the situation. Chunk X. Oh. Yeah. But what if it's negative? What if it's negative? And why do Wait a minute, why are you doing end 15? Why are you doing end 15? We can do module 16. But why end 15? Decimal to binary. 15. Is it just zeros? Yeah, it's zeros here. It's just zeros. And here is 16. What if it's 16? Here 16. Oh, because it's from 0 to 15. And if we do AND, but it will... It's more efficient. Yeah, I think you're cooking, man. But what if it's negative? What if it's negative? Player position integer. Player position integer. Okay. Okay. Now look here, it doesn't continue. But what about here? Does it continue here? Yeah, here it continues. No, what if we remove the scale just to be easier to see what's happening? Let's remove the scaling. Scale, let's do 1, 1. Let's do here 1 or 4, doesn't matter. And here when we divide by 16. So here is scale x times by 16. Scale y times 16. And what now? We did this just to be smaller clouds. Bro, chat is onto something. Now it's not doing it. It stays the same. Let me bring it how it was before. Let me do it how it was before. Bro, what's your problem, man? Your problem? What's the issue here? I changed the scaling temporarily. Here, scaling is 1. And if it's 12, how much time do we have? We don't have much time. Yeah, we do 16 by the scale. That's how we got it before. Okay, we can bring it back just in case. Just remove your chunk. Oh, the if statement. Yeah, the if statement. You're right. Bro, what's your problem, man? I just want to... No, I'll remove the if statement. I'll remove it for sure. But before that, I want to have it like it was before. I want to have it like it was before. Oh, here, I just need brackets. I just need brackets. Just need brackets. Let's test it out. Okay, now it is like before, perfect. And here let's bring it down. And here let's remove the if statement. And here let's have and 15. And 15. Okay, chat. It's still limited when we go in negative coordinates. It's limited, but what if we go here? Here it should be higher. It should continue after 256. It doesn't. It doesn't go after 256. We are still limited to the texture. We are still limited. So here this, why doesn't this work? This is for the end result. Let me think about it. Here we get the chunk X and chunk Y, and it's through the player position. We divide it by 16. And the value will be between 0 and 16, let's say. But it can go higher than that. But our current texture is like between 0 and 15. Is the limits of our texture, what's possible. When the current chunk X is like 16, it needs to go back to 0. Let's actually do online CPP. Here, let's do a quick test. Let's do integer will be 15. And let's see out the integer, which is not an angle, it's test. Let's remove this. Let's have here test. This is width and 15. What do we get? We should get 15 actually. Yeah, we get 15. What if it's 16? We get 0. Perfect. What if it's 17? 1. Perfect. So it's perfect. And what if it's -1? It should be the opposite. 15. Bro, Wix is a genius, man. Wix is a genius. We just need to figure out how to make it work. Yeah, this comment. Wix is a genius, guys. Let's save the W. Bro, look at the W board, man. Look at the W board. How it's going more and more to the left. Bro, if I release a game, I'll just add all of these people into the credits. All of these people into the credits. The W train. And the more you are here, if you are here multiple times, you are higher up the credits, maybe. Maybe. We'll see. That would be cool if the game has credits. The W leaderboard. What were we doing? I forgot. Yeah. Here, this part. This part is perfect, chat. It's perfect. It gives us exactly what we need. The only question is, The only question is, why is it not working? Yeah, here when we're in a negative position, yeah, let's actually debug it. Let's debug it. Let's debug it. So when we're in a negative, here we're in a negative x coordinate. Both of them are negative. Both of them are negative. So let's do a breakpoint. Let's do a breakpoint like this. 13 and 14. 13 and 14. So they are proper values. All the is the positioning. Is the positioning, chat. That's the problem. It's still using, it's still it's rendering it in the wrong position. Yeah. The problem wasn't with the suggestion Wix gave us. The problem was in my way of using it. Yeah, here when we set the position, we're using the chunk Y and the chunk X. We need to do something else. We need to use something else. Yeah, the position is the problem. That's the issue. It's the position we use here. That's the issue. And how are we going to do the position? How are we going to calculate here a position? Think mark. It needs to be based on the player position, I think. No, we'll have two versions. We'll have two versions. Wrap. We'll have two versions. Yeah, we don't need to rely for everything on Wix. We need to think ourselves, chat. So here we'll use the wrap. And for the position, we'll use the regular one. That should be it. That should be it. Okay, we're probably getting wrapping. Everywhere we have a cloud above us. Nice. And now let's scale it up to 12 by 12. Scale it up. And then we just need to increase to have more of them at the same time rendering. It's not above us. Why is it not above us? Let's draw probably wireframe as well. Let's probably draw a wireframe. Draw wireframe. Cube wires. Cube wires. Let's do here vector 3 cloud position. Cloud position will be this. Cloud position. Oh, because it's an integer. Maybe. Here, we'll draw wireframe around it. Here, the cloud position. And then the width. The width is 16 times scale x. 16. Height is 4. And then here is 16 times scale y. color, like we can do black. Only to cast as an integer at the end. Oh, yeah, that's a good point. Here, oh, this is the origin. We need to offset it. We need to offset it a bit. The wires. It's just so we can much easier look at it. Position, we need to do. Let's just draw a sphere at the position. Let's just draw a sphere. Radius of 1. I just want to look at where the origin is. That would be enough. And we'll look at the problem Wix is talking about. Yeah, here is the origin. Yeah, here is the origin. Yeah, we're looking at the origin. We're looking at the origin. So, where is the problem here? Player position, scale, etc. Like this. Have integer at the end, cast. And then here we wrap it. The result is the same. Chat result is the same. Oh, when it's negative, maybe. When coordinates are negative, it's probably weird. Let's draw the actual wireframe. Let's draw the wires. Draw cube wires. Let's draw the wires. Vector 3 cloud size is 16 times scale x. 16. This is 4. 16 times scale y. So here we'll do cloud size z, and we need to offset the wire. Maybe let's just look at the wire, how the wire is. The wire is centered. I want to see just the wire. How the wire interacts. Yeah, wire is just above us. Not always. Kind of. Okay, we can just offset the clouds. Scaling issue. Oh, here it's much worse. We can negative. Oh, chat. Maybe it's because of the negative and positives. Yeah, here when it's positive, good enough. Let's try the negative. Oh, here, where does the change happen? Let's go from 0, 0 on the X. Yeah, here is 0, 0. Here is 0. Here is the 0. Yeah, it changes here once we are at the end of this cloud. And we have 5 minutes. Damn. Cloud size X twice. It's still fine. Like the Z and X is the same. The Z and X is the same. What do we want? We want the cloud that's on top of us. Here, this is 0, 0. And this is positive X. This is 0, 0. And once we are at the end, which is around 200, we go to the next one. That's perfect. And here we go to the next one. Okay, let's go back to 0, 0. 0, 0. We go to the other one. Oh no, here the negative. Chat. This is interesting. When it's negative, it doesn't work. Like here it needs to update, because here, if we go here, look at this chat. Here, if we go after this, it updates. It updates here. That updates. But here, it doesn't, because we're in the negative. Here, we need to reach the end. We need to reach the end when it's negative. Yeah. When it's negative, it's an issue. Yeah, that's the issue. When it's negative. Here, if it's -1, it becomes 15. What should I do, chat? What should I do? What should I do? What if we use just the module, even though it's not efficient? We'll be doing it only once, it's fine. Module. And module 16, I think. It's -1. The other module, the Python. Python online. The other module. Here, I want printf. I want -1 mod 16. Bro, I don't want input, man. Yeah, it's 15. Wait, but it's the same like the and 15. It's not different. It's the same. Like with weak suggestion. It's the same. If we do and 15, it's the same result. Yeah, it's 15, and here it's 15. It's the same. And if we do... So where's the issue, chat? We calculate the chunk X and chunk Y using player position, and when player position is above, if it's so confused, you started using Python. When let's actually do it like this, chat. Let's say this is 16. and we look at player position. What's the player position here, chat? If player position, let's do int player x. Let's say it's 0. And so here we do integer. Brother, I don't want to stand up. We do player x divided by 16. Player x divided by 16. And let's say this, sure. And then at the end, we do this. So when it's 0, we get 0. When it's 1, it's 0. And when it's 15, it's 0. When it's 15, it's 0. When it's 16, it should be 1. Yeah, when it's 16, it's 1. But if it's minus 1, is it 0 again? It's 0. Why is it 0? Why is it 0? Test. Both of them are 0. Let's do float. Let's do no, what am I expecting actually? What's my expectation? It should be fine actually. What's my... Yeah, the problem is in the game. The problem is in game, if we look at here, look at how when x is positive, we are here. And once we go after the clouds, we get the new clouds. This is perfect. This is perfect. When we go in the positive direction, everything is fine. But when the coordinates becomes negative, here it is still 0. Here it is still 0. I want it to be -1, maybe. Maybe. But here, if we do... Let's do this here, chat. Look at this. It's actually... No. Let's do here like this, chat. No. If we do... Minecraft chunk Wikipedia. And here they had the calculations. I think they used a floor, maybe. I think they used floor. Yeah, in the way we create... Yeah, floor. My bad, guys, my bad. So here, if we do floor, should be the proper one. Should be, yeah, -1. Okay, yeah. Oh, it took me so much time. So here, when we get the integer, it needs to be floor. This should solve it. Finally, man. Finally. Not quit, man. Okay. So now, okay. Well, now we're talking. Now we're talking, man. Okay, so we have one single cloud chunk above us that's endless. So if the player moves above him, he'll have one single cloud chunk. And we just need to increase the size. We just need to have more cloud chunks above us. Okay, let's increase the size and let's commit this. We have endless single chunk cloud above player. That's what we have. That's what we have. And so now let's have multiple chunks, which should be simple. Maybe it should be simple. Yeah, this will be the starting point. This will be the starting point, and we'll do from here a for loop. We'll do for int chunk x will equal this. We can even just keep it like this. And this will be chunk y. Then chunk y, if it's... No, we can do something else. We can do int y equals 0, y less than 16. It will be 16. Let's do 5 by 5. 5 by 5. Regions. Or we could do 3 by 3 as well, with the player in the center. We can do 3 by 3. And here we'll repeat all of this. So here we'll do chunk we'll do, let's say this is starting chunk. Start chunk y. And here this will be integer chunk x equals start chunk x plus x. And here y. Like this. This should do it, actually. This should do it. But they will be offset. They will be offset. I just need to position them a bit backward. Yeah, we have multiple ones. And look at how they update. They update. They're higher widget, and they are actually endless. We just need to offset them so we can look at them from behind us. It's 4 FPS because of the terrain generation. The terrain generation is slow. Like our focus is adding as many features as we can, and then we'll optimize. Let's have them be at the back as well. So let's have the player be in the center. That one thread is screaming. Yeah. Okay, if we have the player in the center, we'll have actually endless 3D clouds. If we have the player in the center. And that will be perfect, chat. We are so close. We just need to put these clouds be in the center. And how are we going to do that? We could... The starting point, we could go backward. We could go back. So here, int cloud chunks amount, or like how should we call it? Width, world clouds with 3. And so if we do offset, we want offset by 1. So here we do int clouds chunk offset. It needs to be this divided by 2. And how much will this be? How much will this be? Let's output. Let's output 3 divided by 2. I want a 1. Yeah, 1. Perfect. Should be 1. And so here we do minus clouds chunk offset. Chunk offset. Now it should be with an offset. Should be with an offset. Okay, and they're around the player, and it should be no, a little bit more of an offset. It needs a little bit more of an offset, probably, but if we make them a little bit more, it will be fine. Because currently we are at the starting point of a single cloud chunk. Locally, we are not centered in the cloud chunk. You're my biggest inspiration, and you kept me going on a lot of projects, so thanks a ton. Yeah, no problem, man. Chat is also my inspiration. Without chat, I would have been in a different position with my projects. Here, let's increase and here let's do world clouds width. World clouds width. Let's increase it to be how much? 9 by 9. Let's do 9 by 9. Should be big enough. Should be big enough. 9 by 9. It should be all around us, endless clouds. Yeah, look at this, chat. Endless clouds. No matter where you look, endless clouds. 3D endless clouds. GG, chat. GG. Finally, chat. Finally. And they're actually 3D. They're actually 3D. We just need to color them properly. And they're actually endless. And we need to make them move on their own. We need to make them move. Could we move them forward a little bit? Could we make them dynamically move? Could we? Maybe just change player position. Offset to the player position. Offset to the player position. Okay, chat. What if we do, and it's only on the x-axis? Let's do. Where do we use this? We use it just here. Let's do player position here. Plus. Let's actually do a commit, chat. Let's do a commit. Endless 3D clouds. And here let's do plus get time. Plus get time. But it will be too fast. It will be too fast. It's every second. It's every second, maybe divided by 1000. Let's try this out. No, they will not drift away. They should be fine, actually. Do they move? I don't think they move. They don't. Maybe this is too slow. Maybe this is too slow. Let's do divided by 10. Do divided by 10. They don't move. Why don't they move? Oh, no, it shouldn't be here. It shouldn't be here. No, not here, not here. Yeah, that's a bit of an issue. Yeah, it's actually making a change, but it's like divided, etc. It shouldn't. No, it should be both in both places. It should be in the both places. No, that's perfect. Yeah, that's a great idea. Float x offset. It should be in both places. Bro, don't tell me we're going to solve this as well. Here, x offset, and it will automatically handle everything. But we need to have it be when we render them as well. When we render them, cloud position x. Here, maybe. Plus x offset. I think. Do we need to scale it up? Do we need to scale it up? The x offset here, do we need to multiply it by size, by scale? I don't know. We'll see. It's not changing. It's not changing. Cloud position plus x offset. Let's scale it up. Size, scale x. Now, how much we divided by? Yeah, by the same thing we divided. Bro, clouds are moving, chat. And they should be endless when they're moving like this. They should be endless. Bro, chat, clouds are moving. And I think they're endless. But let's see, chat. Let's see if they're endless. Let's see if they're actually endless when they move. Probably they are endless. Probably. Hope. Let's hope, chat. Let's hope this is just temporarily, just a brief part without clouds. Let's hope this is. Chat, please. Come back. Come back. Come back. Come back. eh. No. The logic is very good. The logic is very good. Logic is very good. What's the issue? What if here I remove it from here, the offset? What if I remove it from here and let's have it be faster, just so we don't have to wait so much. Doesn't load the next chunks. It should load them from here. Yeah, the starting point, we are here we use just the player X, but we add to it plus. Oh yeah, maybe we're doing it the right way when we do plus offset, but maybe it's not the right offset. Maybe there's a difference between here and there. Because here, this is an offset for the, this is an offset. No, it's the right approach. We're doing the wrong offset. Because this is for player position, and here it's an offset for the, no, it should be proper approach. Should be proper. Damn. It should be proper. Oh, what if we do negative? Negative, negative, negative. Negative offset. Come on, man. Come on. Work with me, man. Bro, like I had to, the stream had to end before 20 minutes. I have something in 10 minutes, chat. We have to lock in, chat. We have literally 10 minutes, chat. I need to, we cannot push this even longer. Like we have literal 10 minutes, chat. Because I have something in 10 minutes. We need to solve this in 10 minutes, chat. We need to solve it in 10 minutes. Let's slow it down. Let's slow it down. And let's remove offset here. Let's have it be smaller, like this. Let's have it be smaller. Now it's slower, it's slowly moving, and they're not updating. Why are they not updating? Why are they not updating? Let's have it be a single one. Let's have it be 1. Let's have it be 1. Here, let's have the size be 1. This will be simpler, and let's speed it up a bit. Yeah. This should stay in one place. Here, it should reset. So the position of the model, we are changing it. Position of the model, what if we do here plus offset? Plus X offset. What's the problem? What's the problem, chat? Oh, I have an idea. Let's actually have here be 0. Let's have this be 0. Let's see if it will update while staying in one spot. Look at this, chat. Look at this. Yeah, it's updating, chat here. Is it? No. I have an idea, chat. Let's have it be faster. Let's have it be faster. What is Wix saying? Cloud position is chunk X start chunk. What are you saying, Wix? You're saying? Oh, plus player position. Wait. So cloud position, you're saying this is the chunk X. No, chat, it's fine, chat. We'll end it, chat. It's fine, it's fine. Don't worry about it. Not that big of a deal. It's fine if we don't have an offset. Fine. So we'll do here a 9. X offset will be 0. And X offset. It's fine, chat. We'll figure out the X offset some other point. Yeah, okay, so this is the summary, chat. In this stream, we decided to focus on the clouds. Before, they were a single texture, a 2D texture. and the texture was at a single position. It wasn't endless. And so at some point the clouds ended. But now they are not only 3D clouds, they're 3D clouds, but they're actually endless, chat. They're actually endless, and they stay in the same position, they're static. At some point we'll figure out how to make them move on their own. It will be very cool if we manage to do that, but we literally don't have the time for that. The way we're doing it, we're going over this texture. We split the texture into 16 by 16 regions. For each region, we create a 3D model. We create a model, and where each pixel is a single cloud, where one cloud is 12 by 4 by 12 blocks. And so here, when the player moves, we just calculate which models we want to visualize. We just calculate which models we want visualized. And so now they're endless, they're 3D. We just need to change their colors. We need to change their colors, and we need to make them move on their own. That's basically what we need to do, chat. But this is a huge improvement, chat. This is a huge improvement. I miss her. She's gone. I missed her. We missed the moment, man. She's gone. I missed her. She gave up. She gave up. She gave up, chat. And so that's it, chat. We have 3D clouds. We have 3D clouds. That's pretty good, chat. That's pretty good. So let's see how it looks like from a regular player view, chat. This is when the player plays the game. So you're walking around, you have all of these clouds. Maybe they're too small even. Or maybe we need to bring them to be lower. Maybe they need to be lower, closer to us. We can make them extend further. We just need to change the fog effect. Okay, so to extend further, how is it in Minecraft? In Minecraft, I think in Minecraft they're closer to the player. They're way lower down. Yeah, what if we... Bro, I don't have much time, chat. I don't have time. Let's lower them down. Cloud position Y. The Y world height by size. Let's bring it down by 100. And okay, you guys want them to extend further. Let's do 13 by 13. And in the clouds shader, here, fog start and fog end. Let's have it be 800, and in here this will be fog start plus 50. Here 800. It's pretty close to here. It's pretty close now. But it's fine, chat. This is the stream. I literally have to go, chat. I literally have to go. I don't have any time, chat. Yeah, okay, so bye guys. Like this is it. We'll fix it at some point. Too low, yeah, I know it's too low. Yeah, that's it for today, chat. That's it for today. I'll just change the thumbnail while I am at it. Endless 3D clouds. Safe, done. Goodbye, guys. Bye, 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 bye.